So this video will cover the matrix assignment in which we are going to create a class that constructs a representation of a two-dimensional array. We can think of a two-dimensional array as being this thing called a matrix that is a mathematical convention. But if that makes it more confusing, to be honest, I would just ignore literally everything right here. Just think about this assignment. We're making a two-dimensional array. Pardon me. We're making a two-dimensional array, which basically just contains, it's an array of arrays. We had something like that in crossword generator, where we had essentially rows and columns. So really quickly, since this video will cover making a class called Matrix. If you have not watched the Dice and Danger video, please watch that beforehand because that will talk about essentially what a class is and how a class will instantiate objects of that class. So really quickly, let's just go over the assignment requirements. So we're going to implement a class that implements a matrix objects that stores floats, so floating point numbers. The matrix can be of any size and will provide the following interfaces. So we have a default constructor, so that's going to create a matrix with no rows and columns. A constructor that will build a matrix of two dimensions, so X amount of rows and Y amount of columns. And then a number of other methods that basically, we're going to have a method that can resize the matrix to a new amount of rows and columns. Something that will return a pointer to the beginning of the matrix. Something that will return a pointer to a certain row in the matrix. And something that will return a pointer to a certain column in the matrix. And then finally, a function that will deallocate memory. So that basically just means that we delete the matrix. So really quickly, since this assignment requires using a lot of pointers, I want to just explicitly define what a pointer is, since we have used them occasionally, but never as kind of like a really important educational feature of an assignment. So really quickly, I want to just review what a pointer will do in C++. So really quickly, what happens when you create a variable in a program, let's say an integer variable called x, and you assign it to a value of 25. So what's going on underneath the hood, so basically in the memory of your computer, the way this will be stored, this variable, is we have this variable named x, and its value will be assigned to a certain memory address in your computer. So in the hardware of your computer, there are different kinds of memory addresses, and basically we will electronically represent the number 25 in this address. So you can think of these as kind of like buckets, and in the bucket that is stored at the address of 0003, we'll represent the value 25, which corresponds to this integer variable named x. Okay, and if we create a pointer variable, so this is an integer pointer variable called p, it will store in its unique address, so 000, instead of storing a value, it stores a pointer to another variable. So it will point to the address that x is stored at. So in memory, p will hold not a value like, an actual integer. It will store the memory address of the value of the other variable it points to. So in short, why would pointers be useful? Doesn't this just seem very confusing? Like if we wanted P just to refer to, couldn't we just set P equal to X itself and create a copy of X in there, the value 25? So pointers will be useful in this assignment, for example, since we're going to need to pass into different functions literally the same array, and we want it to, if we pass in via a pointer, it will basically point to the memory address of the beginning of the array. And since arrays are stored in sequence, so basically just in addresses that are next to each other, it's essentially the same as passing in the entire array. So we're going to be using pointers a lot in this assignment because it will be just useful in terms of passing in the array as an object to different functions. So really quickly, I wanted to explain what this two-dimensional array will essentially, kind of how you can represent it. So we are going to be building a two-dimensional float array. So it's going to be identical to this array, except it will store floating point numbers. And in this function, what we're doing is you're making a pointer to a pointer called array. So this array object is one memory address that refers to a pointer. So it points to another address. So, and at the beginning of this address, guess what lives here? A number of other pointers. So it's a pointer to another pointer. So how does that work? So when you assign array, a pointer to a pointer, to new int pointer of space 10, what that will do in memory is it creates a series of 10 other int pointers. So we can see there are 10 pointers here. And what do these pointers point to? Well, we make a for loop that iterates 10 times, and at this array of pointers at each index, so at 0, 1, 2, 3, 4, up until 9, what we do is we create a new swath of memory for an int array of 10. So these will actually store the integer values. So in total, what we have here is, this is a two-dimensional array. And the way we can think of it as each one of these indexes that's a int pointer is the beginning of a new row in the array. So it is two-dimensional in that you can store things at a certain row in a different column. So if you wanted to access the item that is stored in the third row in the second column, we can access it using this double bracketed notation, array 3, 2, which will go into the third row, which points to this integer array. And then we go to the second index in here. So we go 0, 1, 2. And then we take out this value, which is an integer. Great. So we're going to be doing essentially this exact same thing. The only difference is that we'll store floats. All right, great. So I think this video I might do two parts for this video. Just to break it up, because I know there was a lengthy explanation at the beginning. So first thing I would like to do is I want to fill out the implementation file for Matrix. Basically, we know based on the program, the assignment description, what we need, what kinds of functions we need to declare. as well as what kind of properties for matrices we need to have. So we need to have, like, for example, an integer value x that specifies how many rows, integer value y specifies how many columns. So let's just get to that first so we can kind of create a roadmap for what we're doing in the rest of the assignment. So the first thing we're going to do is we're going to create this sort of public and private distinction. So the things that we specify as being public in the class of matrix, they are accessible outside of the matrix class. This is not that relevant for this assignment since we're only building the matrix class. Well, actually, excuse me on that. Basically, this will be useful to have the matrix in the as a public member when we build our test file and start testing the matrices. But basically, for right now, all we need to know is that public class members are available outside of the matrix class, and private class members are only accessible within the matrix.cpp file. This distinction's more practical when you have many different classes operating together, which we're not doing in this assignment. So that's kind of pardon the explanation. And if that was confusing, I can go over that again in class. So the first thing we're going to want to do is declare a pointer to a pointer for floats. And we'll call this matrix. So that's identical to what we were doing in that schematic for an int array, a two-dimensional int array, where we did a pointer to a pointer. Great. And the next thing we'll do is we'll declare the default constructor. So what we did here is this is a pointer to a series of pointers called matrix, which will refer to the 2D array. Okay, the default constructor is the constructor that does not take any arguments. So in order to declare that, we will just say capital matrix parentheses, and that will create a matrix or a two-dimensional float array of size 0, 0. Whereas our next constructor will be a matrix that takes in an int x and an int y per the assignment description. And this will build a matrix of x amount of rows, y amount of columns. Okay? And the next method we need to do is the set size method. And what this will do is it resizes the matrix. And we need to specify the return type for this function, since this is our first function inside of the class. And so what would the return type be? So the set size method, if we read, it's a function that will set the size of a matrix object to x rows and y column. If the matrix already has a size, a new matrix will be allocated and the elements of the old matrix will be copied into the elements of the new matrix. So essentially, we will be returning a pointer to a new matrix. So what I'm going to do is I'm going to, since if we're going to return a new matrix, and our original matrix, for example, is a pointer to a series of pointers that represents a two-dimensional array, we are also in the set size going to return a float pointer to a pointer. So we will write float pointer pointer, and set size, and this will take in int x, int y for the amount of rows and columns. Great. And so set size resizes the matrix to a new value x and y and returns pointer to new array at the 0, 0 position, which is what the double pointer does, is it points to the beginning of the two-dimensional array. The next method we need to do is the get matrix method, and that just returns a single pointer to the beginning of array at 0, 0. So that would essentially return to this location, the address of this location. And so we're interested in seeing where this first pointer's memory address is located. So we're already one pointer in at this point. So we will return a single pointer, so not two pointers. And we can represent that by saying float pointer. This will return a pointer, a float pointer, which will be this pointer, the address of where this 0th pointer begins. Okay. Yeah, pointers are very confusing to talk about. So get matrix, and it does not take in any arguments. Awesome. The next method we'll need to make is the get row method, and that will return a pointer to the beginning of the row at array x, 0. So in this diagram, so in this case, the get row method will return the pointer of whichever row we're interested in examining. So whether it be the 0th row that has all these values, or the 9th row, which has all these values. So it will return the pointer at here or here. And since it's going to return a pointer, it will also be float pointer get row at int x. Great. And the next and final requirement, where are we? So we've done this, okay, we need to do get column and then this destructor function. So two more. So the get column method, this will also return a pointer to the beginning of the column at 0, y. So yeah, the function will return a pointer to the beginning of column y in the matrix element 0, y. So this will return a pointer to, to something in the 0th row at a certain column. So whether it be 1, 2, 3, 4, 0, 1, 2, 3, 4, all the way up to 9. And keep in mind, it won't return the value. It will return a pointer to one of these column elements. So again, we will do a float pointer and then get column at int y. All right, great. So the next thing we need to do is for the private class, we're going to declare some of the property values for a specific kind of matrix object. So let's see, in the assignment description, does it mention public? Okay, so what we're gonna do is we're gonna for any single matrix, we will have an int x and int y value. So each unique matrix object will have two properties. It will have a size, a dimension of x, how many rows it has, and a dimension of y, how many columns it has. Likewise, I am going to put the this is what I'll actually leave this here for now. And sorry, the last thing I forgot was that we need to do the destructor method. Will deallocate, which just means to release what's being stored in memory for this matrix. So you can think of it as the same thing as like deleting the matrix. It will free up all that memory that was being used by this two-dimensional matrix. So we'll deallocate the memory used by matrix. And this is called tilde matrix. And just to keep things nice and tidy, I want to put this over here. Okay, so part one, we basically just filled out the interface file and just talked about what the matrix is. It's a pointer to a series of float pointers, so double pointer. And the next thing we'll do is I'll have, in the next video, we'll go over writing these functions and how we will test some of the conditions in the assignment description. Okay, so that's all for part one. Oh my god, what is going on? Sorry. Stay tuned for part two.